As he mentioned, my name is Derek Decker. I'm the Assistant Operations Manager.
You might want to stand for the people in the back.
Okay. I'm the Assistant Operations Manager here at the office. I've been in this position for about 1 year. Prior to that, I was a senior engineer working on incentive applications that came in through our program. During that time, if I happen to reduce any of your incentives, I apologize. It wasn't, just got to do my job. Prior to that, I worked with Siemens Building Technologies, actually, so I'm very familiar with Siemens. And one of the things that we always did was we worked with building management systems. So it's something I'm very, very comfortable with and passionate about, and excited to be talking about today. So without further ado, I'd like to give our panelists some time to introduce themselves briefly. Thanks, guys.
Good morning. Thank you for the opportunity to be here. My name is Matt Gates. I'm the Director of Digital Enablement for Trane. It's a long title, but basically in our Minneapolis service headquarters, we've built and developed a lot of different softwares that support BMS efforts over the last 8-9 years. And so hopeful today that we can have a good conversation and want to learn from my colleagues, but also anything that you guys can share as well.
Rich Nowak, thanks again for having me, guys. Just so there's no confusion, I wore the exact same suit and shirt for my picture. It's not like I only have one suit, I swear.
I've never seen him in another suit.
So I was told I have to say Tony Pets 10 times as our local rep. While we're up here, that'll be success for us. But been at Siemens for 20 years, running the Smart Building Program, construction sales, strategic projects, and customer workshops. So looking forward to your questions. Are they going to have live questions with us as we go through the panel stuff?
We had planned on using the notepads to write them down, but I'll get a feel for it as we're going.
Okay.
And I guess if we're comfortable with that, I'm okay with it.
Yeah. All right. So I look forward to the interaction with you guys today. Appreciate it.
Excellent. My name is James Platz. I'm the Director of Controls Sales for Johnson Controls for the Western United States, and apparently we don't know that the Western United States starts in the Appalachian Mountains, so I've actually got Appalachian Mountains west and all of Canada, and I've probably held just about every position you can hold at Johnson Controls in the 20 years that I've been with the company. Most recently, I was the branch general manager of our Pacific Northwest division, but I'm right now based out of Minneapolis, Minnesota. So.
Great. Thank you, gentlemen. So I say let's just go ahead and dig right in. We have a lot of different facility types represented here today. So the first question that I want to ask is about facility types. So would all different facility types benefit from a building management system, or will some benefit more than others?
Sure. I mean, of course we sell BMS systems, so every facility should have a BMS in it. But in seriousness, I mean, we work with K-12 schools with office space, critical laboratories. I mean, some it's an absolute must. It's a safety hazard if you don't have a proper control system. Office space, there's a ton of opportunities to use BMS to save energy and improve comfort at the same time. The use cases get different based on what the facility type is, and that's where you can really, today, with like all the new innovations and digital applications, really craft not just the BMS itself, but all the surrounding applications to not just optimize energy, but optimize the environment, create a more productive environment, create a better learning environment for children if it's a school system, or create a just greater energy efficiency in your space.
You know, it's funny, the power of a thermostat. And I'm going to sit there, and I always think when I hear that question, the simplest application we can have is our house, right? And now we think about it today, and everybody has access to a Nest or some sort of thermostat on their phone. And the ability to save energy with something as simple as your house has now changed. Where you can be at Disney World, not that I've ever done this with my kiddo, running around going, I'm going to turn back the set point at my house to save energy. So something as simple as the new modern thermostats being able to take the set points and adjust them remotely. Or taking it a different step, think about a dormitory. I think we were working on a project at the University of Minnesota, and I think there were Trane PTAC units that they were putting in, and most of the time, you walk into a hotel or a dorm and you see the knob just sitting on the unit, you know, either it's hot, it's cold, done. What if you could take that, something that simple, and put a thermostat on it and start controlling it remotely? So that, because most of the, I don't know if you recognize this, but college students, especially in hot climates, when they walk out of the room, they want that set point all the way down so they walk back in, it's nice and cool. What if you could start to adjust that just by taking a simple thermostat? What kind of payback would be associated with that? So when I look at facilities, even the simplest facilities, like a dorm or a house, can benefit greatly from just some sort of automation.
Great. Okay. So as I was saying, since we are the Energy Efficiency Program for Business, we want to continue with some energy-related questions. As James was just mentioning, and you hear these advertisements on the radio saying, if you turn your temperature thermostat down by 3 degrees and wear some warmer clothes in the winter, then you can save energy. I don't think they've met my wife. That's not going to happen. But on a serious note, when it comes to a commercial setting, does energy savings truly compromise comfort?
Yeah, so I'll start off here on that one. I don't think so. I think that especially in a larger commercial or industrial setting, I think there's an opportunity to save energy always. If you think about most of our systems, BMS and others, are being run by humans. And so there's human interaction with that system all the time. I think there's always an opportunity to think about how those schedules work. You know, are they aligned to the true occupancy of that building, and even just how the heating and cooling sequences are running. There's always an opportunity to create an energy savings without necessarily making it hyperly uncomfortable. And I would even say just a few degrees uncomfortable. I wouldn't think you even have to get to that level. I think you have an opportunity to be able to balance the two quite well.
You know, it's funny. Control companies are great at coming out with new strategies to control, new control loops. You know, the best way to save energy? Get people to turn off the lights. Like, get your kid to switch the light switch off, and you're going to start to save energy. And so some of the technology I see that impacts, back to what you said, to change behavior, that's where we're at in this industry I call it an inflection point, because the world truly is changing, and how we use technology to impact buildings. An example would be a K-12 school or a university, where nowadays the technology exists from all companies, right? Where you could do some sort of digital display to talk about who's saving the most energy between classroom A or classroom B, or floor 1 and floor 2 within a university. And you can start to drive behaviors and say, we'll give you a pizza party for whichever floor saves the most energy over a period of time. And taking the technology that a BMS offers, that an energy savings program offers, and utilizing it to change behaviors physically within a structure, that's starting to get really cool. That's some of the stuff that gets me really excited. So, my 2 cents on it.
I think, jump off that too, there's a lot of, energy efficiency, like you said, there's control loops, there's dashboard displays, there's ways to make it visible to people. When tenants see, there's a study that was just done, when tenants see how much energy they're using and it's actually graphically displayed to them, they actually look at that and say now they see something they can reduce from there. There's lots of these dorm room challenges that are being done using the technology. That gets them to change some of the behavior you talked about. Don't leave the apartment or the dorm room at 65 degrees. There's automated ways to change that. And there's ways to also work with applications where the workforce is actually engaged in controlling the building themselves. And there's a multitude of applications out there. And it's interesting, I remember seeing one when I was in New York. We were working with a company called WeWork. You guys heard of WeWork?
Yeah.
So WeWork was looking at a technology that allowed people to change the temperature around them. I remember seeing it and I thought, wow, it's like instead of facilities having control and setting it at 70 degrees in the morning in the wintertime, 74 in the summertime, and then at 5 o'clock cutting it off, that would be the optimal way to control it. We're going to allow people to change the temperature all throughout the space. I thought it would be a mess, and I thought it would really cost a lot of extra energy. What we noticed is when people have control of their environment, temperature is not a reality. Temperature to everybody's a perception. We all perceive temperature differently, right? So, like for me, I'm not the slimmest guy anymore, so I got the vertical stripes. I like 66 degrees, 68 degrees. If I walk into a building that's 72, I don't need 72 degrees. I can sit around with 66 degrees, and maybe I'll get cold in 3 hours, but the time that I spend at 66 degrees in my zone to 72 degrees, that's 6 degrees of savings that we can skim off the top. And I am extremely, extremely comfortable. And the moment I need to change temperature because I feel a little out of whack, it's the fact that I have individual control and it's not somebody walking up to a blank, beige thing on the wall that I'm not sure actually works, gives me better satisfaction that I can actually impact my temperature. So we see that. We see that in the summertime too. We don't need, the summertime, what's the biggest thing that kills you temperature-wise in the summertime? It's humidity. right? So if we wring out the humidity in the space, we don't need 72 degrees in the space. Some people can have 78. Some people at 74 degrees have their desk heater running full blast,
That's right.
right? So when you can give people control over their individual environment, we've noticed through studies that we're saving 10 to 20% off the typical HVAC control systems cost just by giving people individual control. So I think there's a lot of changes. If you talk about changes, right? Give people visibility, one, and then give people the ability to impact their individual environment with new technology. You can see vast savings there too.
That's a great point. So you guys talked a lot about the behavioral aspects of it. Let's get technical for a minute and talk about some of the actual energy savings methods that can be included in a BMS, like, for example, demand controlled ventilation. If you wouldn't mind just informing us a little bit about some of the things that you typically see included in a BMS.
Sure, well, I'm gonna spin it a little bit.
Sure, please do.
Why doesn't that surprise me?
I'm a politician.
I know, you have that in you.
So, and the reason I want to spin it is, again, we go back to demand control ventilation and all these other strategies, but there are so many new technologies that exist right now that can offer you savings that you haven't seen before. And we were actually just talking about one in the back of the room, which is many of our facilities still have pneumatics. You do, right? You still have pneumatics in your buildings. And typically when you think about it, the retrofit cost of a pneumatic system is extensively high because you gotta, may have asbestos ceilings or, hard lid ceilings. And getting to the actual controllers is a pain. But yet we're losing on saving strategies associated with them. So some of the things that I've seen develop and some of the technologies that have come out are, well, what if you could just take that thermostat off the wall and replace it with a wireless thermostat, just charged by AA batteries. And that thermostat could control the set point. That thermostat can then wirelessly report back to some BMS via any kind of BACnet or open protocol, and now give you not only visibility into a space that you've never had visibility before, but start capturing energy savings. What would the cost implications or payback implications be for a simple thermostat in those type of scenarios? So for me, it's not necessarily that there's new strategies, but I just love the way that technology is starting to play into energy savings within a building in areas we never thought anything possible.
Yeah, I'll add another idea around this as well, as far as some of those routines. Of course, there's optimized start stop, there's different types of reset schedules and different things like that. But one of the things that is also now at the arsenal of the building owner is things like thermal storage, battery storage, where you actually store energy and use it at different times. A simple example, even just pre-cooling a building at night and allowing some of that ambient temperature off of the physical environment to be able to use that in early morning times to cut peak as an opportunity. And so I think about, there's many different great subroutines and sequences that you can run as well. But now you guys are also having an opportunity to look at some larger opportunities to say, what if I did things in an evening time or an off hours time, and then we're able to use those energies that I've stored during the day to help cut usage and do energy savings.
And you're so right, it's not even theoretical anymore. So the West Coast, this concept of thermal storage, I thought it had actually gone away for years. Thermal storage and batteries, using batteries, huge capacitors, in the same methodology as you use thermal storage, absolutely on the West Coast, especially in California, it's becoming integral in the way they design buildings again, just to shave off peak demand.
How many people here actually have a BMS in the building right now? So it's like, I guess 65, okay. Just want to make sure before going into strategies. I think.
How many have pneumatics versus GDC? So we got
University of Michigan.
Yeah.
You got everything.
I used to be good at that.
Max was the
I
first.
still do.
Max was the first open system,
Right? Universal integrator, era.
So it seems like we have a pretty good mix of everything here, so that's good.
Yes, I mean, there's a ton of strategies building on it. I mean, we target all the different systems. There's you look at a chill plant, that's probably 30% of the energy consumption in the building. That's a huge strategy to reduce that. There's programs out there to reduce that by, depending on what you're at, 30, 40, 50%, maybe We did a job in New York State. We saved 12%, but it was $2.5 million a year. The incentive company gave us $6 million to do it. So I'm not sure where your incentives are.
Hint, hint. Hint, yeah, hint. Buck up, Steve.
$1 million cap.
So we've seen that. I mean, you really got to analyze the building to see what's the most appropriate energy savings and use cases we can do. I mean, I think we're going to talk later. There's new technology. There's public articles about fault detection and diagnostics that can shave off 10 to 15% of energy cost. It's almost like retro commissioning, but using technology to help you do it. There's also, when we look at a BMS system today, there's more than just, a BMS was always considered HVAC controls. And today we're kind of looking at it different. And we're seeing our customers look at it different. Some of them still have the siloed electrical shop, HVAC shop. We were just in conversations, even just here recently, with some major Fortune 500 companies. And they're looking at their technology different. They want a smart technology roadmap. They're not just looking at a BMS because the BMS is now doing a lighting control. Now the lighting control is integral to it. It allows for better peak demand shaving. You've got on-site battery storage, bring it all together in one box. So we're seeing that the strategies move beyond just HVAC for energy savings. To multiple systems throughout the site.
You're getting me fired up. I'm starting to get goosebumps. You're right. And here's my example. And I talk about it often. So, because I teach our college students that we bring on board. We have an entire generation of folks that are integrated, in essence, to their phone, right? And they look at their phone, and that's the number one thing. They communicate on their phone. They interface with their personal space on their phone. My wife is a great example. We have cameras in our house. I don't know why people would break into our house. I have a 4-year-old. All I have is Paw Patrol, right? So if you want Paw Patrol, break into my house because we've got every single one. But you have communication on your phone to everything. Thermostats, cameras, everything. Now you take that same generation of folks and you move them into a commercial building, to your point. And you're starting to get this expectation of a smart building. What does that smart building mean? And that smart building is, over time, you're going to see technologies like lighting, fire, security, building automation, energy systems, all coming together. It's almost like you can see Alexa reforming itself in commercial buildings. You're going to start to see these technologies come together. Is it 1 year away or 10 years? I'm not sure. But you can see the integrated field of technologies coming together in the same fashion as it comes together in Alexa in your house. It's just a matter of time.
Yeah, I think that putting that stuff together is also helping the pro formas, return on investments for doing retrofits. Working with a customer that they were looking at just a pneumatic upgrade, but when we looked at the lighting, we were like, the lighting is really not where it needs to be. And if we did a pneumatic upgrade, what if we looked at the strategies differently? With the lighting, you guys have sensors on these lights in here. I don't know what they are, but there's lighting that has sensors that can basically count people. So now you look at ventilation codes and outdoor air intake codes. New York City is a great one because you need 10 CFM of outdoor air per person. So what we find is there's a massive over-ventilation of space when no one's there, and there's a potential under-ventilation of space when people are there. But the balance works out, especially in the commuter cities like New York, where nobody's coming to work on Mondays and Fridays, and working from home. And we're finding that when we mix the lighting with a strategy of counting people to interact with an automation system, potentially with an application that can save energy by people conditioning their own environment the way they want it, the return on investment of doing a BMS upgrade is really coming more into the 3-year window or 2-year window or 4-year window, whatever that hurdle rate is, to really help people put together. So all that smart technology you're talking about that the next generation is looking for impacts productivity of the people, but it's also allowing us to provide better return on investment for even doing basic BMS upgrades. That's what we're seeing.
Yeah, okay.
Yeah, go ahead.
Tony Petz, that's two.
Well, no, here's my question though. This sounds expensive. I love all your technology. This is great. I want to have a smart building. But I got realities, right? I have budgets, So, who has, like, how many people have to agree on this, and at what level do we have to get approval financially? And where's the performer coming out? Like, what's my modeling, and how far into the future where I start really seeing the saving? Because I'm constrained, right? I need to have paybacks, right? You know what I mean? And so it's great, but how do you address that? Like, how are we able? Who has to agree, and where's the money coming from?
So that's where stuff's getting cool. This is not a plant question, by the way.
It isn't. This is my frustration as a guy out there having to sell this.
So,
I can cross that one off my list.
It is. It's the reality, right? They'll sell this, but no one's got the money for it.
we're finding that, companies they're looking at energy, right? And energy is the initial return on investment we're trying to do to upgrade a BMS or upgrade a space, right? But there's drivers for it. It could be educational drivers. Let's do commercial office, pretty simple space, right? So commercial office, we're looking at the energy side of a let's call it a pneumatic upgrade, right? Or a BMS upgrade. That's a small piece of what that customer actually cares about, what people care about. Think about it, especially if you're in facilities. You have people that, let's say you're in facilities for a Fortune 500 company that has a human resource department, in some cases a workplace experience officer. You also have a portfolio of real estate managers that are looking at their real estate assets. One bank, global bank in New York came to us and said, we don't know how much space we're using, but we think we're spending $400 million on extra leasing of space that we don't need, right? So when you look at the equation, like JLL publishes the famous 330-300 rule, right? $3 for energy is $30 for leases, $300 for salary, right? So if we think about it, the pro forma, there's a hard pro forma, or hard return on investment for saving energy, but then there's also the soft cost, which is even far greater than that. Intel Corporation is using an application right now that's saving them $80 million on space because they put analytics into their upgrades, into their BMS and their lighting, to allow them to understand precisely, not just that the room is occupied, but how many people are there. All that data feeds into HVAC, all it feeds into the optimization of the BMS, but then they take that data that they're gathering, because if you have pneumatics, you don't have data, get all that data in, now they're seeing real return on investment in space. And then there's the soft cost of the productivity. And if you look at an office space, we're creating a better environment, we're putting in more outdoor air sometimes, better lighting, daylight harvesting, all this stuff to provide a more productive work environment. There's a well movement that's trying to support it, but ultimately we're paying people a hell of a lot more than we're spending on energy, and that's what people care about. So if you think about our pro forma, like to your question, and who you got to talk to, if we're at a 4-year or 5-year payback on a pneumatic upgrade, it might be worthwhile going up in your own organization and say, hey, there's some better things we can do with this space. We can make it more productive. We may be, most real estate is 50% utilized in the commercial office, right? Maybe we can cut down 20% of our office space if we put better analytics into our BMS upgrade and really improve the pro forma outside of just energy. That makes sense, or that sounds too corporate? All right.
That sounds very cool. But it's big, right?
So I'll look at it a different way. So what's preventing us from moving in that direction? Inertia. Inertia of our industry. Building automation is always the last to go anywhere. Case in point, most of our building automation systems still are pneumatic. We've just started to see systems over the past 5 years go to IP controllers. The world's been on IP for a long time. What prevents it? Inertia. Inertia within our design communities, inertia within our facility communities, because when you change, you incorporate risk, right? So there's a ton of technologies that are out there, right? There's these analytics that we'll chat about, there are these new controllers that we'll chat about. The problem is that when you put this into, especially a design, or if you're building a building, you're building in risk because you don't know what the outcome is. If I go do pneumatics, I know pneumatics are going to work. They've worked for 100 years. But yet when I go to IP controllers, that's different. I'm incorporating some semblance of risk. And so the challenge that I've seen in our industry is trying to educate people that the risks are small, that the costs to do the integration aren't as significant as they once were, and that these integrations, if they're built into the designs ahead of time, aren't that complicated. There's huge returns like you were talking about. And so what we fight on a daily basis is the inertia to do things the way they've always been done. And when you overcome that inertia, that's where you start to see some interesting ideas. Because otherwise you're just going to keep seeing buildings the way they were built yesterday. We have to fight that inertia within our industry.
I want to come back to the integration thing in a little bit, but since we're talking about cost, we might as well talk about timing for a little bit, because I felt like back when I worked with Siemens, some of these management systems, and we're talking mid-2000s, could take several months to get everything integrated. Has that changed at all? And what type of what's the typical timing like for installing these systems for one, a brand new system that is pneumatic going to DDC, and obviously you can use ranges, and two, something where there's already an existing system and we're sort of optimizing it and bringing it to the latest and greatest.
So I can start with one of the questions around like pneumatic to a VMS system. And I think you had mentioned wireless technology. That's pretty prevalent in these days. The opportunity to be able to not have to trench through a wall or be able to run a conduit or something to that effect has become pretty much a standard. So that really does do a lot to speed implementation time up, and to be able to also phase that so that each time, maybe on an evening shift as those rooms are renovated, they then become active in the system. So I think that's a new part of what we look at today as a way to speed things up. When I think about higher level integrations, back in the day, there was a lot of gateway devices. And that gateway device can be able to take even an open protocol such as Modbus or something to that effect into a standardized other system. Really took time. It was a technician on a 5-gallon bucket. We all have the analogy in our mind. Really just mapping and doing a lot of that data. That type of technology has changed significantly. Even in the integration or the gateway device now, there's a lot of subroutines where it's auto-finding, auto-looking for, and the agreement around BACnet and open protocols has helped a lot with that, because that is now a standard that all three of our organizations look at and abide by. Then the last piece I think about is really connected to, okay, well, if an IoT device for vibration sensing or for lighting control or something like that is already sending data to a repository, a database, then why can't those two databases be connected via API? And API is really just programming pipeline. And the idea set now is that rather than do all that hard work at the physical devices, where a manufacturer, an IoT manufacturer, has already normalized it and brought it to a cloud so that they can see their data, just share the data between the clouds. And I think that's a big press. And you mentioned the IP technology, and I'll expand a little bit there. Today you could argue that, yeah, IP has some standardization because of our IT networks. But when I think about what Google, Amazon, IBM, and some of the large technology corporations have brought to our world, is we kind of have some standard languages. We can, hey, you're at AWS and I'm, Microsoft Azure. We can pipeline to each other. So that type of thing happens at a cloud level, which speeds, that time to market for sure.
I can't argue with you. I mean, we used to think in the 90s and 2000s about an integration. Simple. I'm going to integrate a fire alarm system. Bucket. I love your bucket analogy, right? You have somebody sit for 3, 4, 5 days on a bucket, pulling in points, organizing the points. What's different today in a simple integration is you can do a BACnet integration to anything. A chiller, a fire alarm system. I can figure it out. I can actually go into the tool. You don't want me working on your tool, but I can go in, click auto discover, and all the points suck in, and it's just how you organize it. Right? So the BACnet integrations have come a ridiculously long way. You can go onto that site, BACnet Testing Lab. You can see what points you're going to get before you even get them. Right? So from an integration perspective, I think the leaps and bounds we've made are that the simpler integrations now, the ones that used to be complex in the past, but where it gets fun, to your point is, I had a CIO for an airport on the West Coast come up to me and go, I have a data stream that tells me how many Uber drivers are dropping off passengers every given minute at my airport. Wouldn't it be cool if I could start to preheat or pre-cool various terminals based on anticipated loading from the data stream I'm getting from Uber? I mean, that's the next level of integrations that's more complicated, but it's opening doors that we've never thought of before. So it's not just the back-end integration of lighting, right? That stuff is easy. It's those type of custom integrations that become more interesting.
So Derek, part of the original question was the implementation time for DNS,
Right.
and then with the integration, right? So implementation time on a pneumatic, I can give you guys a sound bite. We're talking about the wireless technology. That's a great way to go. We're doing $30 million worth of wireless thermostat technology and integration across New York City Housing Authority in 6 months. So we think about that is for a control system. That's basically a $50 million DEC control system if it was wired, right? Because you have the ability to deploy it rather quickly and test it. Part of it is also, control companies are also innovating how they deliver, right? So do delivery. I mean, when you're doing a retrofit, you need to move as much of the labor as possible into the office, get guys off the buckets, like you guys said. So you're doing things ahead of time and planning it. This way, when you're actually doing delivery in the field, you have the minimal amount of interruption in the space. So there's ways to plan around it. So the technology helps, having a better plan helps. It's still going to be an interaction between, we're doing, let's call it a $5 million lab control system upgrade from an old Victoria valve system. And that one took a year in a 500,000 square foot research facility, but minimal impact to the occupants. That's also what we have to look at when we're doing these kind of, it's almost like invasive surgery, right? Just got to really plan it out well. And then you guys hit the nail on the head with all the integration and all the cool stuff that's happening with that. BACnet is huge, it's simple. BACnet instance numbers unlock that controller, and from there you can bring any point you want. If you have a big BACnet facility, or you're doing that, that's where it's incumbent upon you to have a standardized naming convention. You guys probably seen Haystack or something like that, whatever. As long as we have a standardized naming convention, we have BACnet instance numbers, that speeds along integration. There's still, in these legacy buildings, we still need legacy drivers. It's an old proprietary technology that's out there. We all have proprietary technology. There's lots of legacy stuff. I think part of what's incumbent upon us is to really analyze what's out there, what can it do, use that investment as much as it can, look at the integration of what we can do, and make sure that we can leverage it for return on investment. We have examples of that, like Carnegie Hall. Half Carnegie Hall is Schneider. It's all old stuff. And we engineered drivers to old Schneider equipment for some of Carnegie Hall, did a risk analysis. If that stuff failed, what would happen? And then all the new stuff is all new IP technology, like we're talking about, fully integrated smart building stuff, lighting, fire, security, automation. So I guess that would be kind of take on that.
So you kind of mentioned something really quick there about naming conventions. And when I was hearing you guys talk about this, okay, you have all these different things coming in, and it seems like you have a new set of problems that you have to deal with now, and that's different equipment with different point names and things like that. So is that a serious issue, or is that something that you're able to solve easily?
Well, I'd say, is it a serious thing? Yes, and I'll explain. Every building has air handler 1. Every building has, I think my old Landis and Gear days, SCU1 or NBC1 or whatever it is. And I always look at that and say, so that's reality. It's not out of bad faith that got installed that way. But to your point, when you're starting to bring them together, there are now the abilities through the technology layers to say, okay, it's air handler 1, but it's in this physical building. And now, even if they're both, SCU1s, I can now separate those two. And so I would say that it's real, it's out there, but I think we've all adapted to that technology and allowed the enterprise level systems to be able to say, okay, I'll normalize that for you guys. But I do think, especially when you're in a portfolio or a larger level, thinking about a standardized naming convention is a good way for you to plan up front how you want things to come in. Because, AH01 or AC01 or AHU1, you don't want all that you have to kind of understand and try to figure out. You want to be able to try to say, hey, when we do that enterprise level, this is the naming convention that we like. You mentioned Haystack, which I think is a way that we'll all get to that standardization. And even if you don't have that thought process, at least put together your plan and say, here's how we'd like to see it as we start to integrate up to an enterprise level.
I'm going to take this a little bit different. We talked to Apple, and the reason we talked to Apple is because when you open up your phone, an Apple phone, it's just easy to use, right? You open it up, you don't need a direction manual to figure out how to get into it. Now take a peek at any building automation system that's out there, especially anyone that was put in before the past 5 years. It's stereo instructions, and it's done with good hearts, good intent. But you open up a building automation system, and it's designed by people who love building automation systems, and it's organized in such a way that it's by controllers. It's not put in a logical progression that people who use the system think, right? And so one of the transitions when you look at naming conventions isn't just brick or haystack or what you name your points, because I think that's huge. But it's also the next step you're seeing by all the major BAS manufacturers is organizing the data in such a way that it's usable to the end user. Instead of organizing it under supervisory controllers and field controllers, which nobody really understands, it's organizing it in such a way that you see, okay, it's air handler 1. Air handler 1 has 10 VAV boxes under it. It should be really easy to find those 10 VAV boxes when looking at the system, and really easy to see what boiler serves those so that I can troubleshoot quickly. So part of the other thing about naming conventions is also just the organization of how we look at the data within a building, and then on top of it, making sure the points are normalized to the right data static. That starts to, now all of a sudden you're changing the end result. Now you're changing how people interface with the system, saving time and energy, and finding troubleshooting and opportunities for savings.
That's a great point. It's huge. The naming conventions were always just unarbitrary. We had the opportunity to work with a major university in New York. You can't hear back there? And part of the fun of that was they were creating a whole brand new campus. And they looked at it as, here we have an opportunity to do everything right the first time. And we looked at the naming conventions of everything, mechanical equipment, all the stuff in the controls. What you're talking about is huge because when you create the relationship inside the naming convention of how the equipment works with each other, now you're creating the dependencies with which you're going to future troubleshoot as you move forward with your technology. You're also, quite frankly, what you're laying the foundation for is, new buzzwords, this digital twin stuff. You're laying that foundation because the whole point of that is to understand relationships between all your VAV boxes and your air handlers and your air handlers and your boiler and chiller plants. If you do it the other way, it's a lot of human intuitiveness we're going to need. And we have a lot of people retiring in our facilities departments, so we're losing a lot of that intuitiveness. So we have to embed it in the technology so it's much easier to see. And that's where this naming convention and your associations of equipment is huge. Plan that out right.
Great points, guys. Appreciate it. I feel like we're kind of leaking into the world of analytics a little bit with some of this talk about bringing all this data into a central location. We've recently started to use some analytics, some DTE data to kind of look at target markets in our industry and see the underserved areas or the people participating versus not participating, and it's brought a lot of value to us. So I'd like to ask you guys what exactly you think is the value of analytics and just anything that you want to talk about related to the use of analytics in BMS world.
You have visualization title. So we see, I segregate things in my head, and maybe it's not right, but I look at analytics as, that might be strange. I look at analytics as one piece, and I look at fault detection as another piece, and I look at predictive fault detection as another piece. And then I also look at, on real time, I look at artificial intelligence and machine learning as other components, right? But we'll just go analytics for this.
Okay.
Yeah, so when I look at analytics, this is just a different way to slice all the data that you guys are getting in your system. If you think about it, like you said, we have all this data, air handler 1, trend data. The way it used to come out was a spreadsheet of 1,000 different temperatures. And if you're real smart, you'd graph it, tabulate it. But we're finding different ways to tabulate the data that we're getting so that in a moment's glance, you can look at it and say, holy crap, I didn't know that was happening to my building, right? That's the value. And a good example is, so we have a global financial customer out of New York. We're fortunate enough, we're the only provider for them. We do this global BMS system. We've been doing it for 25 years, right? Our BMS system is beautiful. The floors in this place are beautiful. The operator that operates this building, you can eat breakfast off the floor of the machine room. Like, that's how clean this place is, how well run it is. And we got people on site, and we think everything's great. We decided to run an analytic across the air handling units. What we didn't realize was they have a data center that requires cooling 24/7, but obviously in the wintertime in New York, you're not cooling the rest of the building. Turns out that the pressure we had to run to get water to the data center was actually unseating the valves in the air handling units, right? We didn't realize this because everything runs like a clock. It's 55 degrees. It's being delivered from supply temperature to every VAV box. The traders are very particular people. These people make millions of dollars a month for this company, so it's so important to be 55 degrees, 72 in space, and all that. We run one report, and we said, let's just do a simultaneous heating and cooling analytic on 16 air handlers in this building. We found $10,000 of wasted simultaneous heating and cooling across between 10 degrees, and we looked at the bin data, between 10 and 50 degrees outside. That's where we're actually overcooling the building without realizing it. We just had no idea. And these guys are looking at graphics every day. We're looking at graphics every day. It's $160,000 a year from one single graphical analytic. So we're taking this one graph analytic, bringing it to all of our customers and saying, hey, let's just try this in your building and see what we find. So when we see analytics, that without getting into the fault detection stuff, it's just right there, having a different way to view your data, customized to that building can save a ton of cash.
I want to come back to the fault detection because I think that's a really good additional topic. But
Yeah.
do you guys have anything you'd like to add about the analytics side?
The only other thing I'd throw out there is that most modern BAS systems have some sort of analytic capabilities, right? And you just don't know about it. And the reason, again, is inertia. Inertia pulls us in such a way that that's something that's different, and lots of times people don't realize. Go ahead.
All right, I am at the University of Michigan.
Yeah.
And
Go Blue.
Sure. There's a gentleman from Siemens who may have heard of us, right? We have some of your stuff,
Yeah.
a lot of it actually.
Yep.
From my standpoint here, is what you guys can sell in the future, at least to places like us, is that service of analytic information. We have a massive problem where we have the potential to collect all kinds of information from our building automation system. And we have people who do that, and they run trends, and we do all this other stuff. But we do not have the time or energy to actually, there's nobody who is completely dedicated to finding whose job it is to provide to be constantly paying attention to that data. And that's a very expensive and complicated thing to do. And that is something that I would think that you guys would be looking at and licking your lips as an opportunity to extract huge funding streams from customers like us for providing that more than just, instrumenting our systems.
Sure.
And so kind of other questions that I have coming up here about, for example, doing the analysis of human behavior modeling. So you mentioned, for example, that you've been building a lighting system. We're going through pain and suffering now, trying to integrate lighting systems through VA, through BACnet, okay? And the people here who should be here could tell you about how, you said it's very easy. Well, okay, but, they're having, it's a little harder than it seems. But the point being that now we have all this, and we're just trying to keep it run. So what we need is somebody who is going to be able to do this in an effective way, to come back in and find out, how do we use these rooms? What should we be measuring? And then having the measurements, what we do with it.
Sure. Yeah, that's, what you're saying is, we hear that from a lot of customers where, we need a real technology roadmap for this stuff. I agree with you on the lighting side. There's the theory of things being easy because of BACnet. Something that James actually mentioned was really appropriate was we see a lot of lighting vendors that come to us, and I'll give you, I don't know if I'm allowed to say the names, but there's a major university I was part of in New York. A lighting vendor came in, runs with Megatron, and their system was impossible. We spent $100,000 integrating BACnet, easy way, into their system. Even when we finally got the point names, we found they couldn't support the traffic speed that we needed to get all the occupancy data to do the resets in the labs. The other thing was the articulation of the point names. They're not part of the point name convention strategy that we put in to Columbia University, to that university. So the biggest issue we had then is we had to say A151325. We have to get our Captain Crunch wing out and figure out what that means, right? So that was kind of that's why people are talking about this stuff, the point naming strategy and all that, because that's real important. I think it's a remiss. That's something that we ought to talk through is who's on the site that's not helping you look at that data, because that data is coming in, and it's really about having the right people, on our team or whatever control team you have to make sure that we can articulate that in a way which will provide more value from that data.
There's something else too. Once we build a building, and now you own it, right? And then you've got this, you take a dog, now you commit yourself to all kinds of other activities that you may not have involved in. Now we have this information. If we're putting this stuff in, and we want to make use of it, we now have to add positions, right? We have to add intelligence, human or otherwise, either local or purchased, on an ongoing basis, right? So there should be some sort of a cost element for, all right, how much does it cost? Now you build this new building and you have this new system here, and we have this data collection capabilities. How many FTEs, man hours, human positions do we now need to fund in order to be able to use the information and also sustain the quality of the information that is there, because the sensors degrade and things miss, and somebody has to be paying attention to it.
Yeah.
Are you guys selling that?
Yeah, we have so that's an overall strategy.
Because we won for decades. Until the building's decommissioned.
No, you're right. That's an overall strategy. So I don't know how your maintenance is set up. Which not have a lot of.
Which we do. No, we do.
Yeah. But we have a university that came to us. And they had tons of deferred maintenance, and they were on a reactive maintenance protocols, what they were doing. Because they didn't have the data from the systems and the intelligence from, let's say, the fault detection to allow them to change their maintenance strategy. So their people, they had large contracts to FM providers just for regular maintenance, and we were in a reactive maintenance position with them. What we had to do is embark on a new strategy with them. It took a lot of planning. The idea was to go from reactive to go to predictive strategies. That allowed us to work with them to reduce the number of people required to do the reactionary maintenance. And essentially, they also were able to reduce their FM contract to their provider. I don't know if you have that, but so we got out of the deferred maintenance and we went to the predictive. So what we're doing is taking bodies that were running around fighting fires and just stopping that and saying, all right, now that I have this data, let me be more targeted towards what I'm doing when I'm doing it. So there's less reaction, there's less physical labor required to meet the requirements of the university, and then just using more intelligence from the data in the system to help us do it. It sounds like a simple thing. It's harder than what I just said, but
we are doing analytics.
Richard said something earlier, sorry.
Yeah, go ahead.
Richard said something earlier around, when you look at the pro forma, you've got to think about all the costs, because I think what you mentioned is very real. Because that inertia that James mentioned, it's really time. I never had any time before, and with the do more with less thought process in every business in U.S. and Canada today, you're not going to have any more time. So your idea is correct in that if I'm going to reduce costs significantly through that effort, what will be those either other FTEs or outsourced services that I'm going to need? And looking at that total pro forma to make sure that you're accounting for both that savings and those additional costs, because that takes time. And those larger, I'll call it more campus level or enterprise level planning is a hard part to do. But if you're going to overcome that inertia, that part has to start, because otherwise there is no time. And I always think about, even in my role in my cost center that I manage for Trane, my job is to figure out a way to say, okay, look, I have a lot of turn the crank and turn the crank and turn the crank, but if I'm not thinking about what's going to happen next year or what's going to happen in 2 years down the road, and for corporate world, that's probably an eternity. But if I'm not doing that, then I'm not moving that inertia, because I'll just fall victim or struggle in that reactionary effort. So I think think about the pro forma as the big picture, the bigger enterprise picture of the plan, enact that, and then make sure that, I think one of the things you said, James, what I really like is really, what does that data tell me? In reference to what is always the question you want to ask, because you think about the temperature, hey, it's 28 degrees outside today, or whatever it was. Like, compared to what? Is that good? Is that bad? And we know that we're losing a lot of that specialized knowledge as people retire out of our industry. And we're going to have to use that to build it into the analytics, because it's going to have someone say 28 degrees is actually a lot colder normally than here, and you're going to be using a lot more heating, and then you just echo all of that up at a higher level to be able to get analysis that means something to you, as opposed to it's 28 degrees. Okay, great, thanks.
We are already doing that, by the way. We do have a consultancy arm that does analytics.
Oh, I know.
We have shared access to your BMS.
Yes.
Right.
Yes, that's what we're,
Yeah.
the contracts that are, it's a matter of committing to that one way or another, right? When you buy computers, you have an IT department now. You never did. There were no people like that. Now we have hundreds of them.
So I'll tell you just an interesting side story. There's another Big Ten university that I work with a lot. And that particular university has used a lot of the strategies we've talked to up until now. And what they say is, look, in a modern world of openness and BACnet, we're going to competitively bid every job that goes into this campus. We're going to integrate them all into a centralized workstation, because everybody plays with BACnet, right? All of the teams up here, we have teams that play with BACnet. But what became interesting about analytics is they said, we see analytics, both of you mentioned it, as a way of looking at predictively figuring out where the problems are going to be, as opposed to reactive. So whenever I think of analytics, I'm always thinking of the fact that we're trying to hit the problems before they become problems. Because right now, when a BAS system gives you an alarm, something's broken. Temperature's hot, the filter's dirty, pressures are high. You're in a responding mode. as opposed to looking at things going, hey, we think you're gonna have a problem here in some given time period. And so this particular university, I'm gonna ask, because you got my curiosity up, if they actually hired people to do this, or if they just took a period of time and said, we're gonna focus on the predictive analytics in lieu of responding to issues, because if we get them up front, they're not gonna percolate through we're not gonna see as many percolating through to the responding issues. So they started focusing more on the predictive side, and they've implemented these kind of analytics that we're talking about on like 60, 70 buildings right now, and seen massive energy savings, but I don't think they hired a whole bunch of people to do it. They just shifted the focus of their existing base to make them a little bit more efficient, I think. But it's a worthwhile question to ask.
So we have a university down south that was able to take $1 million out of their operations and maintenance budget, going with predictive versus reactive. And it's probably worthwhile, if that's a track you want to go down to, even interview the heads of their facilities departments and see how they do it. Using the data, like you just said, the exact same strategy. We use the data to change the maintenance program. Reduce the once we got rid of this reactionary pile, we moved into a predictive pile, really taking the FDE data from it. They're actually moving to the next step with us as almost a partner on the implementation of the predictive learning algorithms. So now what we're trying to do is get ahead of the fault detection. The fault detection is kind of things like tube fell off the VAV box. What does the VAV box do when the tube falls off? It fails flow to 0, so it goes damper wide open. What does the reheat valve do? It goes wide open, maintains 72 degrees in the space, everyone's happy. You don't realize you're wasting energy. And then all of a sudden one day the temperature gets the conditions are so bad you can't maintain it, that's when you realize, right? So that's what a fault detection does. What we're trying to do is do predictive learning to understand before we see the faults, to see what's happening within the machinery itself. Predictive learning would be like fan failures, right? Vibration analysis for fan failures. So right now, this university is using just the predictive, or just the fault detection, and they've gone down $1 million a year in overall facilities and maintenance. I think it's a worthwhile discussion.
You know what's funny about that though? So I present across the nation, right? We do these sessions a lot. And I walk into consultants' offices, and this is almost universal. And I say, what is a fault? And they know they should know the answer, but they don't. And that's okay, because it's relatively new terms. But this concept of fault diagnostics is one of the next game changers in our industry. And the problem is because our design communities aren't comfortable with it, right? Inertia just keeps pulling us. It's not getting integrated into the design processes. And typically it becomes this aftermarket thing that the BAS folks are trying to add onto the system to add value. I mean, just a simple definition of what is a fault. We all know what an alarm is. Alarm is when something comes outside of conditions that you've given it. Filter's dirty, temperature's hot. But a fault, those are those questions within a system that there isn't an alarm that's being notified on. My favorite example of a simple fault was, what if the set screw on your actuator is loose? Actuator's opening and closing, damper isn't moving, right? And so there's conditions happening within a VAV box or an air handler. And those conditions are being driven by something that's broken, but the system may still be outputting, right? It's 55 degrees, 72 degrees in the space. You don't know it. So you have opportunities for energy savings that aren't being displayed anywhere in the BAS. That's when you start seeing that what a fault is versus what an alarm is. And until we as an industry, owners, contractors, and consultants, are going to start to understand this and believe in that technology for energy savings, it's just not getting implemented in the buildings.
I think when you think about fault detection, we had a good example with the set screw. We built a LEED Platinum academic building in New York, and 5 years later came back and they were doing enthalpy economizer when it was 97 degrees outside. Not realizing because the set screws, they took the actuators off the dampers, they didn't know how to use them. But the fault detection, if you're an owner, and our consultants need a lot of education in this, and if you're a building owner, you should never accept a specification for an automation system without a corresponding specification for how you're going to use a fault detection system to understand if the BMS is doing it right.
Amen.
And what people don't realize is you have a sequence of operations for enthalpy economizer, right? You got a couple paragraphs for how it works, optimal, right? And the side piece of that should be, now here's how we're gonna check how it's working, right? And these are the rules that come within the fault detection. So you could have 1,000, 2,000 rules, but you wanna pick in a specification, what are the 3, 4, or 6 rules that are most important for that unit as part of your specification, your BMS strategy. It's integral to it. There's a few consultants that understand it, but for the most part, they don't. Another reason why we want to do this is, like when we talk to consultants about designing a new building, we say, all right, so we'll put fault detection in this. Now let's talk about, let's say, for instance, a filter switch. Do we really need a filter switch anymore? If I have a VFD speed, I have static pressure, why am I running a stick of conduit? Well, I don't know what it costs in Detroit. New York, it's like $1,500 for a filter switch, right, to get it in. Conduit, wire, switch. Then I expand the conduit I run to my fan, put a vibration sensor on the fan, redeploy that capital, because there's fault rules that are now going to use the vibration and data from the variable speed drive, which are already backended into, to tell you you've got a future fan failure happening in like 2 weeks or something like that. The thing is, our consultants don't understand what's in the pipeline and what's in the FDD rules, so then you're not getting those in your specification exactly what they be. And the reason we want to do that is, it's cheaper for me to run a conduit during construction day one than to come back and say, oh, hey, let me give you a predictive maintenance program. Oh, by the way, you're missing these 5 sensors from your unit to do it. You know, that's kind of where we look at that. Yes.
So what I see is there's like kind of not a divorce, but like just like a real separation between like our design teams, project management teams, and then our operations teams.
Yep.
And so the communication about what the operations team really want in a building, it just sometimes there's just a big old wall right there, and it just never gets translated over there. And like U of M, we have design standards, our own design specs, but we are currently, as an organization, trying to drive to the lowest cost possible to construct a building. And so a lot of times, like these additional sensors are the first things to go. I mean, like we've had like instances where like we're trying to put, like they've even VE'd out CFM sensors on supplier streams, and it's just like, okay, how are we supposed to?
Well, we want our atriums.
Yeah.
We gotta have your guys who make these chillers, I'm a chiller person. Why don't those chillers have integral vibration sensing systems on them now when you buy it? Why isn't that built into the OptiView and the AdaptiView? Why don't we have that? We don't. We have to pay somebody to go out there and climb up on the stupid thing and take the readings and then hopefully collect them and then send them to us, and I'm supposed to look at them, but I'm busy. And
No,
that should be in the chiller. My God, that would cost you what, $15
think
for the part?
Think about what she just said. You're right. Think about what she
And
just
then we
said.
got to get our people to put it
How
into
do
the spec.
I
We
get
need to
that
buy this.
capital project? How do I get that capital project to its lowest possible cost? That's the inertia.
It's inertia.
So if
Just described it.
If I, on the Trane chiller, build in that vibration sensor, and no offense, but as York does not, I'm at a cost disadvantage. Because in
But how much would
spirit,
it cost you to develop the in your next revision of the AdaptiView?
yes.
Right.
Oh, and that is
To put in the capabilities.
vibration sensors on that.
Because you just write that code
But
once and
remember, on
it's there.
bid day, added value means absolutely nothing.
Not necessarily.
This price is $100, this guy's $90, he's better.
Not necessarily.
But think about it, it's
Depends how it's
100 years of building that inertia, say lowest cost wins. And you have to be careful in what you put your IP in as a manufacturer. And I could appreciate you would look at it and say, wow, what an excuse, Gates, right? Okay. But I look at it and say, what do I put my IP in? And what's valuable to the customer? And when a capital project has a floor, I mean, this is what it's going to cost, or ceiling, this is what it's going to cost. It shall never go across that. Because it's not like, oh, I'll just go get some more money. No, there are no other monies.
Exactly.
So the ability to look at that is the balance of what any of us do.
Now bring it down to local
How do we get
government.
to that?
So this is the focus of us, right? I mean,
Right.
we're buying the building automation, but I'm now throwing this back to you guys to say, okay, I don't know if you're in lacrosse anymore, they've shut it down or whatever.
We're still building chillers.
That's where you're doing it, okay, cool, that's good. But, so how much would it cost for Trane to say, hey, we're gonna build into the software, right? Because the AdaptiView, right, you've got architecture there that you can very cheaply add on the possibilities and stuff. And then we can sell them the sensors later as an additional thing. So why don't you get into a bidding war with those guys for adding that kind of extensibility.
Yeah, well, some of that is available. Some of the thermal wells are there, some of the other points
Yeah.
to be able to add that sensor. And then it's the next step is, okay, so now on an OpEx, I come out and I say, okay, I've got to add 4 sensors to be able to engage a different group of analytics, and that's still a cost.
Yeah.
And it's a pressure. And you're not wrong, I get you. And I think all of us are making decisions to make connectivity a standard, to use some of the reinvestment of capital away from a flow switch to a vibration meter. So that trend is happening in our business. But I also understand the reality that, guys, it is going to be a capital project. And all of us have to have a competitiveness and a profitability level to be able to say, how can I make sure that I have an opportunity to win?
All I know is that when I bought a dishwasher, and it has the same, it has the same board in it for all the models, right? And in order to get the model with, I don't know, a beeper that plays the tune when it's done, as opposed to the one that doesn't, they've already made that investment. They built it in when they designed it. It's just a different screen with another button that I can press.
There are a lot of that.
So it's all there, right?
So
It's just, they're gonna rack me for the additional $50 for that additional part.
Can I ask you guys a question?
I think before you ask though, I think you guys are talking about something that's, so with any one of these things that save on the OpEx side, I've seen it. We work with a ton of institutions that do that, right? I've got a capital cost pressure here, and then I've got an operations cost pressure here. The thing that we can add to that would be the ability to assist in some way. Somebody cares about both in the University of Michigan, right? I mean, I would imagine.
Oh, yeah.
So whoever cares about both, that would be a good place to say, because they may not be able to quantify what's the value of that additional sensor. And that might be something where in 5 other projects or 5 other schools that we've done and used a CFM sensor, we'll say, right, airflow sensor. So we're using an airflow sensor for this specific analytic. This is the approximate value over a 5-year span to the university. So it might be, this helped us save $3,000 a year for 5 years on average for systems like this. So this is a $15,000 savings. And they can say, all right, it's a $5,000 airflow station, so that's a 3-year payback to do it. You know, and it might be worthwhile looking through the instrumentation of your specification with an eye to that. And that would be where industry can help probably provide some of that financial data to whoever maybe cares. That'd be my best thing I could say.
Where can we find that?
But we have metrics on that. I'm sure anybody has metrics on what we've saved. I mean, one of the things that fault detection, there's multiple programs out there. A lot of fault detection programs will actually say, here's, based on utility cost, here's what the savings. What we try to do is organize it, so our system should have it. I have to go back and see, but because normally what we try to do is, here's the 10 biggest issues with your fault detection engines identified in your campus. This one is, like I just said with the financial institution, this one's costing you guys $160,000. You want to fix it? It's going to cost you $10,000 to fix it. That's how we kind of try to organize it, you know? So maybe we take our historical logs of what that is with different customers and say, hey, look, this instrumentation you're looking for with this analytic has saved these customers $5, $10, $7, and $3,000. You can use that data maybe to help you get it into the spec in the future.
So the most fun jobs I've ever had, most fun jobs I've worked on aren't the ones where we end up bidding a spec and trying to figure out, read intent into the spec at the end of the job. The most fun I've ever had is sitting down with the owner, contractor, the consultant beforehand, and working through these challenges up front and making sure that we set the expectations right so that when it does come out on the bid, everybody's getting exactly what they want. Because otherwise, look, it's funny, our reputation is building automation. If you think about it through the years, we're the last ones on the job site, we're the last ones involved in the design, we're holding up retention, right? We're usually, nobody's ever going, oh boy, the BAS folks are coming to solve my problems, right? There isn't that, you don't feel that. You feel the pain. But the part where it gets more fun is when we're involved up front and we say, okay, here's the spec. Here's what we've got. What do you think? Is there somewhere in here that we should be looking at it from a different perspective? And any one of the companies up here is capable of doing that. You start to get those thoughts integrated into the design before it bids. And so you know what the intent is up front. Because the challenge we keep running to is inertia. And I know I'm overusing that word, but it truly is. We keep doing it the same way. because we have a spec we believe in. We don't necessarily want to change it because if we change it, it's risk. So I'm just going to use that same 15900, 23800, whatever the spec section is. I've used every time before. And we know it works because we've used it before. But once you open that up for a little bit of dialogue and conversation, you start to see that maybe there's other trade-offs. The number of specs I've gone through, my favorite one, fire smoke dampers. Fire smoke dampers are the devil to BAS systems because they're like triple covered. Sometimes the transformer is covered under electrical, sometimes it's covered by mechanical, sometimes it's covered by controls. And on bid day, I'm looking at a spec that says all three. What do I do? Right? So in many cases, we can go through and clean up some of that stuff and capture savings and clear up the dialogue before we even get there so we can pay for some of this stuff. It's not that people do it maliciously, it's just these specs are that thick. You're gonna have redundancy. I think that the more communication we do up front, especially on these critical projects, the outcomes turn out so much better. And it's really hard to have a conversation about a change order when you were involved in the design. Trust me on that.
I think it's a good point for sure. That discussion up front allows you some of that flexibility. The other thing that is interesting is that if you look at certain industries, what's the expected ownership of a building? In the commercial office world, that might be 5 years versus a university where it's the lifetime, right? And
So we're counting, so.
Yeah, so but some
We've
of
been
this,
there for 100
right,
years.
so you guys have that longer
And
term
still the
ownership.
same.
And thinking about that on the design review is another important part. Look, guys, I'm trying to get this investment to a spot where I can flip that building. And at that point, I don't have a longer term engagement with that building after that. That's the next guy's discussion.
Is there a question back there?
Yeah, just that, I think building automation system's a great tool and a great way to save money, but you really don't want to be, you can't forget about preventive maintenance. You still, hands-on preventive maintenance will alleviate a lot of these faults you're talking about, and commissioning. Have a commissioning agent come in and commission your project before you sign off on it, and every 3 to 5 years, you're going to have recommission.
Well, I would say that the technology change, and agree with everything you said except for that last statement, is I would say the technology it's continuous commissioning with the analytics. Because rather than an event, and you get that alligator tooth of performance and energy efficiency, the technology is available today from all of these companies to say, I can hold those gains. I can bring you back to a level of performance, and because of the thing like you mentioned with the set screw, these are the real things that even a smart technician isn't going to be able to see. If it's not in alarm or it's not uncomfortable, they're not going to see. But that's the only caveat I would put to your statement.
Well, the commissioning, you're driving every actuator, every valve, every damper.
And I would say that the interesting part about the analytics, that just as a paradigm shift, is that it's watching that damper in its normal operation to know that it's stroking and nothing's changing on an output, as opposed to a physical event of let's stroke it right now and see what happens. So that's the cool part about the analytics. I would agree that you want that commissioning, but I think the neat part about the technology now is that that layer lives above and doesn't continue.
Yeah, maybe you go 10 years and that's great.
Yeah.
And the other thing is on your front end, you should be able to see a damper issue with your discharge air. Would you see that?
You're definitely right. At every front end, if I go into any BMS system that's been out there for 5 years, it could be mine if I don't have FDD on it or something like that. It could be I walked into a competitor's out on Long Island, and within 5 minutes, I can find 35 issues just like that, right? Because you look at it, or I'll find a VAV box that's at its minimum damper position, but it's discharging 3 degrees below set point. It's trying its heart out, but no one realizes that the static pressure could have been reset properly. It's not done right. Or we'll find a unit that's been on 24/7 for 3 years, right? Stuff like that. That's why we're using the analytics, because what you said is we don't want to employ the person to sit there and just go through every graphic. You have 1,000 VAV boxes, you have 1,000 graphics, right? 15 air handlers, you got 15 graphics there, plus the chiller plant. And you got someone going through it and saying, all right, so these 15 VAV boxes are served by which air handler? We looked that up. Okay, it's this air handler. We look at static pressure. Everything's on point because the air handler's fine. It's making 2.5 inches. But at that moment in time, 2.5 inches is overflowing static pressure to the first floor. The VAVs can't turn back on. It happens in every single solution. That's why we're using the FDD. That's what retro commissioning, if you do retro commissioning 5 years later, that'll fix it that day, right? But, and it's the same with our service program. We show up and do preventive maintenance on our service program. Our technician looks at the system that day for that load, for that's exactly what's happening, and we check off and say, yep, everything's perfect. 4 days from now, after we switch seasons, it may not be that way. That's why we want the FDD to help us drive our maintenance more efficiently, and then keep, like you used to say, keep it optimal the whole time, not just when we show up.
I'll take that. I love what you said about the VAV boxes, so I want to take that one step further in this retro commissioning thing. We had a hospital customer in the West Coast. Had something like 2,500, 3,000 VAV boxes. So that's a lot of VAV boxes, right? And they were some of our older N2 technology. So from a Johnson Controls perspective, it's older stuff, right? And so they said, okay, we want to go through a retro commissioning project because of the fact we have all these VAV boxes and we don't know necessarily, so we don't want to take the time. So we want Johnson Controls, we want you to go through, check all these VAV boxes, give us a price. So we said, okay. So we sat down and thought about it. So there's 2,500 VAV boxes, right? Figure 2 people have to go, 1 person does the suit, the sheet that goes up to make sure the dust doesn't come out because it's a hospital, and then strokes the valves open and close, dampers open and close, 1 person to look at it to make sure it's actually moving, half-hour piece, so $1 or an hour's worth of time times a labor rate times 2,500 boxes plus travel costs, right? And you start to get a really big number just to look at a bunch of VAV boxes and recommission them and make sure they're working right. And so the question we came across was there a better way of doing this? And in this particular case, that's where we said the analytics was an option. Let's overlay the analytics on top of the system. The analytics are going to look for those things that we aren't catching, and they came back with a report that said, hey, instead of checking, going out and physically verifying 2,500, 3,000 VAV boxes, we think you should go look at these 60. And based on the way these things have operated over the past 30 days, we think this is the problem that's associated with them. And oh, by the way, if you fix it, you can save this much money so you can prioritize where you spend your time with retro commissioning activities to focus on the ones that are going to have the biggest bang for their buck. And oh, by the way, it doesn't just impact your VAV boxes. We can put it over your air handlers as well. So that's one of these inflection points we're hitting with the industry, right? And we've still got to figure out how to make it so that you're not hiring a whole bunch of people, because that's critical. But
We're either hiring them ourselves or we're hiring you. I mean,
But that overlay, the savings we're starting to see just in that particular project, and not having to call somebody out to go physically verify all these, that's where this transition is happening. And that's the fun part of where we're at.
So are you saying in order for me to get maximum efficiency in my campus or in my building, I need to partner with one of you? Is that what you're telling me?
You need analytics.
But I mean, is that really what we're at? I mean, because this is the question we come up with, right? I mean, are we, would you all agree that the most efficient customers, the most efficient buildings that you're managing for your customers, you're partners from the beginning, you're partnered with them?
Every one of the examples that I said, without trying to say the names, we're a partner at a high level with that institution, with the official game plan of how we're going to go attack all this stuff.
Right.
With buy-in from facilities, from construction, and even above when there's other strains or stresses on the organization.
But how do I know you're not going to take advantage of me? As you notoriously in the past have all taken advantage of me. Each one of your companies, mine, yours, have all gouged me. You hit me with change orders that are ungodly, right? The markups are just really almost usury, right? This is a fact. Everyone knows it in the industry. So how do we change that conversation so I can trust partnering with you?
I think Fred said it well, it's the ROI. What's the savings that you guys are getting to? And document it so that that's, it's like measurement and verification, that it's validated and real. Because it's hard, especially you were talking about operational savings, to say, well, if I've made a team more productive, can I prove that? Because the finance person would say, I'm still paying that guy's salary. So is he more productive or isn't he? So you've got to make sure that that validation on the tail end is a big piece of it so that you can see or validate those savings. And we've seen that in studies as well, is that when a customer sees a true validation, they're 3 times more likely to buy from that organization again. So I think that's the last step of it, is put the reasonable level of validation costs into the front side of that project so that you can say, put your money where your mouth is, Trane, JCI, Siemens.
I think the partnering, because it's two sides of the equation, right? You have a partner for the life of your buildings or institution, and you also have a partner during the construction process. And that's, I mean, you touched on it earlier, is there's so much waste in specs. There's issues in specifications that as a bidder you try to bring up, but you're always trying to figure out how to play it right. But ultimately, partnering with an organization means partnering on a design process, partnering from the beginning of the project, so you can get the intelligence out of whatever partner you think can bring the most value to your institution. But that's where we find either overlap or efficiencies for savings. We can redeploy capital. You'll see 5 networks go into a building for facilities, 5 individual OT networks, you know, things like that, because that's how it's always been done. You know, we'll look at that and say, well, why don't we put one network in, make it a bit more robust, you know, put in the right cybersecurity for it, so it's not, you know, easily hackable, just like you know, just some switch that's not managed, you know, to do it. Redeploy that capital towards a couple extra sensors for the fault detection to help improve the maintenance program in the future. And then I think you said it best too. You know, when you employ a partner, you go from a bid, a reactionary bid situation with a change order philosophy, especially through the contracting tier, to more of a design build. Because when you're sitting across the table from your partner, deciding on a strategy to better optimize whatever it is, right? And you forget something as the trusted partner, you can't really say, well, I forgot this, but I want you to pay for it. You know, that's the point you made. I mean, I did that in New York. I took a BMS, lighting, shade control, electrical power monitoring, individual spec for a bank, just doing 200,000 square feet of office space. I went to the contractor and the customer and said, guys, we think we can save you some money. Ultimately, we saved them a couple $100,000 on the build because of all the redundancies and networks and systems. And I forgot the plug load control in my lighting core. So what am I going to do there? Right? I'm going to say, look, I basically design and build a construction spec myself and said, here's what I'm going to do for you and save a bunch of money. I can't come back and say, oh, by the way, I forgot this. You know, so we ate it. You know, that's what you do as a partner. You just give and take. So I hope that answers part of the question.
Yeah, I just think that conversation comes up, but this is great, and I agree with you. Let's say he agrees with you, but there's these people down the hall called procurement, and they're paid to interrupt that.
That university example I gave you before,
Yeah.
you can be a partner and still get competitive bids. You just can. The world is getting flatter and it's getting more open. So in those particular cases, in this university, it's the second largest square feet of any university in North America.
Right.
We bid on every single job, right? But they still have a consistent head end using technologies like that and working with the design engineers and making sure the design engineers work with the control and BAS providers so that we're aligned appropriately when the bids come out. It's just that simple extra step, and they still get their competitive bids. They still have a single user head end, right? And the systems are open enough that they don't have to call one of us every time. Heck, right now, this university, they do their integration all by themselves. They don't call us to do the integration. They just integrate the other buildings. So competitive bids still exist. The systems are open enough that you have options, but yet you can still have those conversations.
So have you reviewed, any of you reviewed the specs before they went out to bid and doing your input on possible savings or things that were missed? Because you're answering a bid, it's kind of a little too late.
Right.
That's the problem, is when by the time the bids have come out, there's a lot more rigidity in the process, but I have spent way too many hours looking at specs, but it's not just my section of the spec, it's other sections of the spec too, and how they're gonna interface with others, right? So I'm gonna have a rooftop unit, or I'm gonna have something that's gonna come with factory package controls. Well, okay, so what does that mean? And what's the communication on it going to be, and making sure that that's aligned right with the control spec so that all the stuff that you need on that unit is going to either be provided by the unit manufacturer or by the controls provider. Does that align? Simple things like that, and then using, you know, Adobe Acrobat, just redlining it and offering commentary back. Here's my thoughts, what do you think? Because consultants, your asset is your time. So if I can make life a little bit easier by reviewing these specs and clearing it up, it's just gonna make everybody's life easier, because otherwise it's bid day. And I love what you said, bid day, contractors love taking the lowest price. They do. And so if I'm stuck looking at a spec and I see that that fire smoke damper, there's 15, 20, 30 power supplies that are in my spec, but I also see they're in the electrical spec, and I also see they're in somebody else's spec, I got a decision to make. Do I carry them or don't I? All of that could be resolved early if we would have just had a chance to go through the spec and cross those things out. And that happens a lot.
Well, great conversation. Rich, you mentioned something about cybersecurity, and I think that's kind of a hot topic these days. So I'd like to talk about, we face a lot of cybersecurity threats, and I think it's something that we should discuss a little bit more. So.
Yeah, I mean, cybersecurity is huge and it's pervasive. It's not just the controller. It's not just the network switch. It's interesting. It's created the need for new partners. For us, in the past, we partnered with sensor companies and valve companies. And now we're partnering with network gear manufacturers on a very high level because the cybersecurity equation is more than just our controllers. It's our network. It's what switches we're using, what's managed. It's what testing and validation we've done ahead of time. We've got a real great partnership with one of the major network switch manufacturers where we've tested it so that we've improved the envelope of their cybersecurity capabilities or the software they're using to develop a full smart building. Because one of the questions we always got is we'd say, all right, your BMS can be smart, you should have your lighting on it, you should have all these systems on it, sounds really cool. Everyone's like, well, holy cow, I've got one basket that if I have one cyber attack, my entire building's down. So we listened to that and we're like, yeah, you're kind of right. So we sat with multiple switch manufacturers and took all the cybersecurity that's embedded into our product, worked with them to really harden the entire network infrastructure. We've hardened how we do communication in and out of a building to cloud systems. We've hardened cloud systems. And we've hardened all the processes that our technicians utilize for software updates to align better, because we're working with institutions where, if we take down a data center for a major financial firm in New York City, they may have spent $25 million on a BMS, but they're losing $25 million a second that their system's down. So it's life. It's beyond. It's the most important thing that we deal with today.
And it was interesting, when we started this event today, I'll add a little bit, I agree with you. Dan, you mentioned, how do we get out of here if there's an emergency? And we all think about safety. Safety is all of our jobs. It's not just the safety compliance officer or the safety EH&S department that someone might have. And I would look at cybersecurity risk now and say it's an industry issue, not just for BMS or BAS, it's for everybody. And so same kind of idea set is how do you make sure that you're using the best industry standards? Those change every couple years, if not faster. So those all have to be updated, the patches that have to go out to make sure that you're aware of whatever the latest threat could be. And so I think we've all learned that partnership. The other piece of it that's interesting is that when you think about IT of any company, they have to manage a lot of risk. So an easy answer, and you hear it all the time, we will not allow any data outside of this, whatever it is, to the cloud. It's just too risky, I don't want to get there. As you start to have those conversations with that IT group, and you start to think about the inertia of the world, the effort is, guys, it's cloud oriented. I'm not saying that on-prem is dead or any of that kind of crazy stuff, but I would say that it is cloud oriented. There's a lot of positive reasons for the why to that, but I look at that and say, then you just have to sit down and say, how do we mitigate some of that risk for you? Is it something else we add, an appliance, something that helps you get a little bit more secure and feel that way? Because those analytics sitting on that top to hold those gains is worth some of that risk.
What do I write into our request? So we're connecting our chillers. Right? And I'm going to do all right. And the university's got a special problem because, of course, we're supposed to be as open as everything. Right? It's even worse. We're using Gmail. But so I'm thinking about okay. What could possibly go wrong? Right. Anyway, but the hospital doesn't do it. But wasn't it an HVAC contractor?
The target range.
In Atlanta, who was a third, like a guy they hired later to do some service on, I don't know whose system it was, but it was a major ransomware attack, right? And it was the outside little Bob's Heating and Cooling or whatever, with a software package that he had, that he was connecting to, you know, a thermos, you know, so how do we, you know, all right, so now we've done this, and now how do we get, so how can you protect us? What do we have to ask for when we're writing this up? Because that proposal I had for connecting the chillers, I don't know, I put some stuff in there about, but I don't know what to say.
So most of us have written a specification that help with some of that internet security language. You know, what are some of those norms and things? So I think that's the starting point, because that's a new part of the world. You know, we think about that, you know, I grew up in that section 1900 and stuff kind of things in my day, and now it's like, but that's a whole new section that has to be a part of that. So I think that's one starting point. And then that partnership, when you think about planning, you would want to talk to procurement to understand their process so that you can still get competitive bidding. And now and you also want to talk to that IT department. Say, what is your standards and how do I apply to that as well? So that's the get started point, but there are some languages available now for specifications.
You know what's funny? Here's another topic that nobody seems to have totally wrapped their head around yet, but it is going to change building automation in 2 years. And that is the ASHRAE Secure Connect standard. Because right now, the wonderful thing about BACnet is it's open. I can connect to anything. The worst thing about BACnet is it's open. And if I want to, I can connect to anything. And if I have malicious intent, that's a problem. And so if you ever Google BACnet Secure Connect standard right now, it's out for peer review and it'll probably be approved here in the next couple of months. It's talking about encrypting BACnet, having an encrypted BACnet from point to point. And so this is going to physically change the way networks come together. It's another one of those topics that we keep missing as we look down the future, making sure that the devices we're putting in are going to be able to accept that standard. Because when I started in this industry 20 years ago, I mean, I had password on a server, and that password was password. And that was everybody else's password as well. There was no such thing as a firewall. We connected it to Comcast and life happened. And I still, one of my least favorite days was when I got a call from a facility manager, and the facility manager said, my system's going slow. I can't figure out why. Back in that day, there was a company called Napster. And somebody had figured out how to use that server as a file sharing place for all sorts of material, and there were thousands of people downloading it off this particular server in an elementary school. This is a huge issue, right? And so things like FIPS 140, things like BACnet Secure Connect, these technical languages, you know, these technical standards are going to be more and more incorporated into the BAS language to help protect our end customers. And on top of it, it's also, I hate to say it, but it's a function of who you select. In the case you just said, it's 3 guys in a truck, right, that were hired by a particular company to do work. Well,
They didn't even know they had the malware on them.
Right.
Yeah.
They had computers that they didn't even know they had malware on. Well, now if you have a computer that you don't know you have malware on, but I have a VPN access into your network, suddenly I've created a path for that malware. So part of it is understanding who the folks are that are actually doing your work and having a trust factor or an understanding that they have really good IT security on their own. Because if they don't, and they don't have the protective software on their computers, you're at risk. That's what happened, right? And of course then more gates get shut down and you don't see that everybody know cloud computing and you can only use one computer on a job site. All those things change, but it really comes back to also who you look at as your provider or providers. Because there isn't just one or two, there's lots of folks that do it. And there's risk there.
Your spec has to be more than just the technology side. That's generally what goes in there. It has to be, you probably should be asking your vendors for their policies, procedures, and internal training, and methods of operations, or MOPS as we call it, so that you have, because if you think about it, it wasn't truly the BMS technology that killed that site, that had that. It was basically the IT protocol of that company. They probably didn't have much, and the procedures that these people use to get into their own system. So that's why cybersecurity is not just a technical item, it's really a procedural training.
I'm going to jump in because we've got just a few minutes left before we're going to wrap up. And I think this has been extremely engaging conversation. And we've talked about these two this question I'm going to ask as a final throughout. We've talked about some of this, but I'd like you to summarize in 1 or 2 points how you think the customers and also yourselves can advance the industry over the next 5 years. What are the most important things that you guys can do? And that we can do as customers installing this to just keep this, you can't use the word inertia. So anything besides that.
How about convergence?
That's good. I like that.
IT convergence. So one way or another,
He's so fabulous.
like you can stay. IT convergence. The world is moving, and you can feel it every day. You can feel that everything's moving towards either wireless, even in your house, or plugged in on a Cat 5 or a Cat 6 cable, just an Ethernet cable. This IT convergence is hitting us quickly in the commercial industry. So things that we can do is start to recognize it and start to break the cycle that's been repeated over and over again of doing things the same way. Recognizing that we're at this inflection point in the industry, just like we were when pneumatics went to BAS. We're at that same point. And recognizing there's a ton of power that can come from the BAS systems, the analytics systems that are around the corner, and helping us move the industry to recognizing that. It's funny the number of times I look at systems right now, and we look at MSTP, I'm gonna use the term, right? The standard systems that go into a building. This is technology that's been around for 30 years, and yet we're still putting it in. And my favorite story to tell is, this will be how I end, I promise. I bid a hospital once in Oregon when I was branch manager. This hospital was a $20 million controls project. $20 million. It was right at that point in the industry where we were going from our legacy N2 product to BACnet. And everybody looked at me and said, so what product should we put in? Because the spec was open. I looked at it and I said, you know what? We're going to go with that legacy product. Risk averse, met spec, but it was the right thing to do, right? Because the operations people would like it, we would less risk. Fast forward 5 years. That facility manager came up to me and said, let me get this straight. I just put $1 billion into a hospital and $20 million into your system, and you're telling me it's outdated? This is the scar I live with today. And so my challenge to us in this room and the entire industry is you sit back and look at it, we're at that same point. Are the systems we're putting in today ones that in 10 years we're going to look back at and go, that was the right decision? Or are we going to put in systems that we're going to end up saying, boy, I wish I would have looked at this a different way?
Cool. So I think there's a lot of change happening in the industry. If you think about BMS controls, how many guys have been in the industry or have known about it for the last 10, 15 years? Part of it, a couple people. If you think about it, kind of like what you just said, the biggest change to our industry was we went from a proprietary twisted shield pair to a BACnet twisted shield pair. And the big change we have today is we have IP controllers, right? That's been the biggest change up until probably the last 2 or 3 years. In the last 2 or 3 years, I don't want to say it's like a Silicon Valley, but the barriers to entry to our industry have gone down because now everything has gone more digital, right? So we're giving people applications in the palm of their hands to change how their environments work. We spend probably half of today not talking about the system itself, but talking about how the cloud systems are enabling us to make the systems more efficient. What we're finding is the things that we're doing digitally are opening up greater and faster change to our industry. It's also this convergence from typical standalone OT networks, operational technology networks, to putting everything converging onto an IT backbone, is bringing the technology together, and it's allowing us different avenues to purchase technology more efficiently and then make technology work together more efficiently and leverage the cloud infrastructure and all these cool analytics and machine learning and artificial intelligence to bring this stuff for far better outcomes. And if you think about this, it's going beyond the people that are in this room. If we're in facilities, the impacts that we're having are to our human resource department because we're providing a more productive workplace for the people that are in that space. It's to the head of academics inside of a college or university because the systems themselves are providing more productive classroom environments. The systems can actually determine which teachers keep a full class size throughout the entire semester. If you think about it, right? The systems are able to provide more valuable and more data to enhance the student experience. The systems are being used now at many universities as part of the engineering program. So instead of students learning about control volumes and whatever, thermodynamics. They're learning about, by the way, here's how this is actually running this building. Here's what a chiller looks like. Here's what a cooling tower is, right? Here's how enthalpy works. I know when I went to college, it was all diagrams on a board by a professor I didn't understand. Now we're giving people real world access to real systems because we're able to converge this stuff. But honestly, like you're talking about, I'll use your inertia word. Everything we've done in the past, the waste stuff, we had to use it once. We didn't want to. But when we talk to it, like we sit down with customers instead of, we don't just sit down with facilities. We just had a customer conversation yesterday, and we're talking to human resources. We're talking head of workplace experience. We're talking to architectural, and we're talking to mechanical, electrical, and plumbing in one conversation to talk about how to make their technology smarter. We had a company just come to us yesterday. We had a phone call at 3 o'clock to set up a workshop because they're like, workshop us through, help us connect our own silos. Because the technology today is allowing us to connect silos, provide better value across the institution, not just energy savings. So that would be the change that I see and the opportunity for all of us to do.
I don't have a lot more to add. I think I agree with everything that my two colleagues have shared. I'll put out, because you would ask, like, what are some things that you guys can do today? I would say that we all three would love the opportunity to work with you on a design review or a spec review. And any of our account managers would be in that area to say, I would like to do that. Because I do think there's real savings and real opportunities to make sure that you get what you want. The next piece is, and also be comfortable with the legwork of IT is going to be in that discussion. Procurement will likely be in that discussion as well. And so that it's a kind of a whole process for you. And then the last piece I would share is, because the technologies are improving, more and more every day, think about that ability to say, this is something in our industry, we're all struggling to find qualified technicians to come into our labor force. You guys are, we are, everybody is. And the reality is, all of those experts, those functional experts that we've had for decades, our average service tech age is now in the mid-40s, average age in the mid-40s. And I look at that and say, this technology is our best chance at capturing some of that domain knowledge and putting it into the analytics, into these neural models, all this fancy technology stuff, to be able to allow you guys to have the best technician of JCI, of Siemens, of Trane, looking at your system. That's what's going to happen. So be comfortable that those analytics will become a part of our effort, because it's our best opportunity. And then lastly, because I think you mentioned about cost and how to balance the cost, make sure that you've got some form of validation that you are comfortable with. It doesn't have to be to the nth degree, but it has to be that you're comfortable with, so that any one of us are held to that standard. Thank you. I agree.
Great, yeah. So communication, collaboration, all those things. So
And that's work, by the way. That's a lot of work on both sides.
Yeah. It's interesting to hear they're doing that in the classrooms too. I mean, that's very exciting to me, because that's a shift in the right direction. Because just from when I was in the field to today, it's remarkable how much has changed. Like, I've learned a lot today, so thank you, gentlemen. Are there any other questions from anyone out in the audience before we let Dan take over?
I just want to let them know I'm going to write an email address on the board. If anyone's interested in learning more about the Smart Building Infrastructure Group that Rich leads, he flew in from New York to be here with us today. I can help coordinate that and put that together for you. So I'll have an email address on the board for you.
Okay, great. Scott?
Sort of a two-part question. Do you guys know, for any customers that you work with that have existing buildings, what's the majority of people, are people installing a brand new BMS where they don't have anything already, or are they trying to replace some kind of outdated, non-functioning BMS?
So say the scenario again, you've got an existing building with an existing system.
Well, any customer that you're working with that has an existing building, what's the majority? Are they, if they're installing a new BMS, are they installing one where they don't have any kind of a system, or are they trying to replace an older system?
So,
Are you dealing more with new or upgrade?
So, well, most of the building stock is existing versus what's going to be built. So that's there. But within the existing building stock, my personal experience is that there's BMS systems that have been put in the 80s, 90s, even some of the early 2000s, and there's either issues with the service provider or the technology's out of date, and there was no backward, forward compatible roadmap from that institution that put it in, and so they're looking to upgrade it for that. I can tell you, in New York City, developer buys a building, they go flip it from class whatever to class A. First thing they do is they upgrade the BMS, and there's always some twisted shield repair technology that they can't do anything with, and they have goals to do all the stuff we talked about today. We wind up trying to reuse wires and stuff, or even in some cases give them the option to reuse wires or bring it fully up to IP to prepare for the future. That's kind of what we say.
That's my experience. Is it's a Barber Coleman Network 8000 or something like that. Sorry, but it's an older system that's getting upgraded, and I think James said it, and we all said it. Is there's where wireless is an opportunity, because there's this theory, and it's part of our inertia. Sorry, I'll say I claim that one there. Is that
So we all said it now.
when I say that, guys, if it ain't broke, don't fix it. It's 15 years old, it's 20 years old, and there's no compelling urgency to rip it out because it's working to a level. But when I think about wireless, it's like, all right, cool. It's not important to go out and rip out 500 VAV boxes, but as they fail, go wireless, because eventually you're replacing that over time. So it gives you that ability to say, maybe there's a way to change the financial commitment so that it's not a huge CapEx investment to replace the whole lot of it. Now, if you get the money, great. But if you can't, then there's at least a way to create a program and a plan that says we're going to migrate out that old technology X% a year over the next 3 years, because there is some reality on all of our systems that the stuff's solid. It doesn't always break. It's rare that they just blow off the wall for no reason.
It's funny you say that. So I was telling my peer about Pelican Bay Prison, I think is what it's called in California. It's a prison where it's super duper duper max, right? The worst of the worst end up in Pelican Bay Prison. Screwdriver in, you have like 3 people to check your screwdriver as you're coming in. So they just don't replace the system. And so in those cases, you've got systems that were put in, in the 70s. They're still operating. And so there's a compelling event to change it. But my answer would be, it kind of depends, and I know that's a terrible answer, but that's where the conversation sits down. You go, what's your situation? What's the implications of replacement costs versus integrating costs versus doing something new? And then it depends on the market. When you ask about whether or not you're doing retrofits or new construction, San Francisco was ridiculous for a period of time. And there were towers going up all over the place, so nobody was doing retrofit work, everybody was focusing on the new towers. Other markets, there was a lot of retrofit work because they had the existing infrastructure in place and they were just trying to update it. Because you have a ton of campuses right now that are looking at refresh. You've got campuses of big manufacturers that look at Google, they look at the huge Apple donut that they built out in Cupertino, and they're trying to compete with the same people that are coming out of school, trying to get them to come to work for them as opposed to going to work for Apple. And one of the ways they do that is through their campus, right? Microsoft, same kind of a deal. You have buildings that are 20, 30 years old. Are they going to draw the same kind of people that are being drawn from a Google or a LinkedIn? That's one of the other things we're seeing from a draw in the industry.
Yeah, all three you mentioned wireless thermostats and a lot of capabilities. Is any marketer out there, do they have, because I haven't seen them, the actuators, are there wireless actuators, wireless, damper controls? Because if you got an automatic system, you're still going to have to go in there and rip all that stuff out. So that's where I'm at. The wireless stat sounds great, but I've got pneumatics, damper actuators.
Right. You got to look at what problem you're solving, right? Wireless stat, you're right. If it's still pneumatic control, it gives you a little bit of idea what's happening. You guys have wireless actuators?
I think some of the actuators are starting to accept like a Zigbee over BACnet signal as an acceptable signal, but you still got a power loop.
Otherwise, you're going to have a massive battery that you got to charge.
You still got to run stuff. You got to do some wire. You use existing conduits, but you have holes in the wall that you're going to be running.
That power draw on that actuator, even though it's a small VAV actuator, is still strong enough that you wouldn't want, with today's battery technology, because I'll never say never, you wouldn't want a battery operated system there.
Yeah, that's what I was thinking.
But technologies will get better, And I even think about CO2 and humidity that draw a little bit more power out of a wireless sensor. All of us have worked to try to modify that so that most of us have, I'll just call it, from a Trane perspective, lifetime batteries that are 15, 20 years, because the power draw is so small that you can use AA off the shelf, you know, buy them at Walgreens, whatever, batteries, and allow it to work that long because it's got that long-lasting ability. But the actuators create a little bit too much power.
I was thinking about K-12 applications.
Yeah.
Every classroom's got a unit ventilator. Or
So there is still the problem you're solving is you're still going to have some actuator rework at the effort, but that wireless comm or the wireless sensors at least cuts a big huge chunk out of that installation.
Good thing about PTAC over there, I mean, your unit ventilator, you've got power there generally. So then you're throwing a transformer, popping a controller in, wireless to a stat, wireless comm back. Pretty intelligent without really being invasive, you know. I just have to get the antenna like outside the metal enclosure because there's no one messing around with it later on.
All right, I'm gonna get going with the rest of the presentation. I think you guys will probably be around for a few minutes afterwards. If there is still questions, feel free to network for a little bit. But thanks again, panelists. Thanks. All right, so it'll be about a 5-10 minute presentation, but real first, by show of hands, who has submitted an application or participated in the program? Okay, so a refresher for some, but like a lot of new faces and new customers. Do a quick program overview, just talk about the timeline, how to apply for incentives, how to make sure you receive the incentives for projects you might do. Not just BMS systems, but we offer all sorts of incentives for lighting, pumps, boilers, chillers, furnace, anything that can save you a kWh or an MCF, there's an opportunity for an incentive. And then go into our catalog and applications. So something really to keep in mind, and we're getting close to this date for 2019, we have a set of incentive funds. Once they're gone for the year. So depending on what you're applying for, you really want to make sure your application is submitted before you start work. We reserve the funds so you don't lose out on those incentives that you're looking for. Watch the gauges on DTE website. We also have other websites. At the end, we can give you some information how to make sure you can see where you're up to date. So at this point in the year, if you're about to install a BMS and have it installed, you want to get an application in right away, get it reserved so those funds are available. When you start the program over, the funds start again, so it's not as crucial on certain measures. And we'll dive into that more, but November 30th is a really important date to keep in mind. So some of you are familiar with this. This is Michigan Public Act 295. That's what started this whole program back in 2009. It's a surcharge that's on everyone's bill. Now it's called energy waste reduction, but that's what drives these programs. So you're paying into this program. So it's really important to take advantage, do some projects, get some of that money back that you've been paying into in all your bills. There are some changes in 2017 that increase the efficiencies of what we're trying to do and increase goals. But it all started with Public Act 295. Since 2009, we've paid out about $206 million in incentives to commercial customers. It's about 58,000 projects. And then the savings, so huge savings, almost 8,000 gigawatt hours of electricity, 20 million MCF, and 500 million in total energy costs. And then since this picture, I put on about 25 pounds, so just for the record. Here is an example of some of the savings. So each car here represents 100,000 vehicles driven. It's almost taking 1 million cars off the road every year in savings. And each house is 100,000 homes, so almost 800,000 homes in energy use a year. And that's only 1 year of our program. And then 7 million tons of CO2 not pumped into our atmosphere. So what we're doing is helping the environment, we're helping our customers, we're helping you afford to do some of these energy efficiency projects. So it's a win-win for everyone. To be able to do a project, first and foremost, you got to be a DTE customer. You got to have DTE gas or electric or both. It's got to be a capital investment. You have to have an invoice for some of the new equipment, have a meter, be in good standings with DTE, and then this is a commercial program, so you can't be a residential customer. There is an asterisk here, though. We do have a couple opportunities if you're an ag customer. I don't think anyone here is an ag customer. You can't receive an incentive if you're self-direct. There's only a couple customers that opt out of the program. Load shifting, fuel switching, you're just tweaking a system, so I know retro commissioning came up a few times. Saves energy, great opportunity, but for our program, you have to be spending money on a new piece of equipment. You can't just tweak something to get more savings. So this is a snapshot of what we saw during 2019. And I'll kind of explain more in a second about prescriptive versus custom. But a lot of lighting. So there's still a lot of lighting opportunity. We've seen a lot of lighting projects this year, HVAC, and then some miscellaneous and process electric, but heavy lighting HVAC. On the natural gas side, predominantly HVAC, along with some process equipment. And a lot of process electric. In our custom projects, process gas. So these are the three opportunities to apply for incentives. You got prescriptive, custom, new construction. The BMS incentive we've been talking about today would be a prescriptive incentive. So these are our predetermined incentives. You're getting X amount for taking out an HID, putting an LED. You're putting a VFD on a system, or you're installing a BMS system in your facility. There's different units that are going to be per pump, per horsepower, per square footage. Those are going to be prescriptive. Custom, kind of like I said, there's any opportunity where you can save an MCF or kWh, and you can prove to us in ways of either M&V data or other sort of information you can provide us. There's a potential chance for a custom measure. And then new construction, major renovation, kind of fits in the prescriptive approach, where your certain measures are going to be the same for both. The one thing that's really different there is lighting. Lighting is going to be based on watts per square foot. So there's a baseline of how much lighting you can have. If you come under that usage, there's an incentive. So prescriptive, again, it's that predetermined amount, and there's opportunities on both the electric side and the gas side. Quick example, Sharon, can you want to start passing those out, actually?
I will.
So this is one example of a BMS system. The total project cost was $265,000. Total incentives, $60,000. You get your project costs afterwards, your total kWh saved, MCF, and simple payback, 5 years. So this was a prescriptive incentive that they received on both gas and electric per their square footage. Obviously, that's going to help you on your payback. So we talked about cost a lot. This whole program is to help you forward and to drive you into systems like this. And then again, it's a prescriptive on both electric and gas side. These are 2019 incentive rates, so they're subject to change in 2020. But it's $40 per 1,000 square feet. And that's not just your building that happens to be 1 million square feet and you installed it in a closet. It's per controlled space. That comes up a lot. So we really need to see a plan of the controlled space.
Is this installing new or replacing?
So I'll get into a little bit. It's 100 for 1,000 square feet too. That's the gas side. But so we have a catalog, and there's a few slides coming up. It can be for installing it new. You don't have an existing system. Scott brought up that question. Or it could be replacing an inadequate system. So it's case by case. This one does require a reservation. That means you got to get application in. Our engineers will review it and make sure it qualifies before you start spending money, start installing it. But it's case by case, kind of what the panelists were talking about. If it's outdated, you can't replace it. You can't get new controls for it. It's done. It's end of life. It can't be fixed. So now there's way to improve it by installing a new system. So it can be both. It just depends what you have in your facility. So in custom, again, it's a capital investment that we don't have a predetermined incentive. We need to see a little more information, some of your behind-the-scenes engineering that you've done to come up with this potential project.
Okay, I'll add something there, Dan.
Yep.
We don't see a lot of custom web-based building management system applications, but we have been starting to see a few more in the recent years. And with the ability to specifically meter pieces of equipment and facilities, it's something that we are comfortable at least taking a look at. Just keep in mind that we will need to see the detailed calculations behind what are we assuming that we're saving. Right? And then we'll reserve funds based on that, and we'll require actual trend data or power data, meter data, in order to validate those savings after. which be patient. We probably won't take a week like we would for like a lighting project. We'll probably need a longer period of time to validate, like say 3 to 5 months, so we can get some of the different weather, for the seasons as well. But we will take a look at it.
And that's instead of like the prescriptive where it's based on different units per different types of technologies installed, this is just based off of a kWh saved or MCF. So that's
Prescriptive is only based on scheduling and things like that. It doesn't look at some of the advanced things we're talking about. So we definitely want to capture everything we can and provide the large things.
So for the new construction, I kind of already talked about, but you got lighting power density. That's the biggest difference from prescriptive to new construction. It's based on watts per square foot in a certain area. So you have so many watts you're allowed in an office building, in a hospital, a manufacturer. There's different levels. And if you're coming under that baseline, that's where the incentive's based off of. In the application, there's a hammer and wrench next to the ones that are eligible for new construction. So on BMS, it's prescriptive. It's not available for new construction. LEED, in case this is something some of these facilities are thinking about, LEED is another opportunity where we base it off of USGBC's review, and these are the rates it's paid out. So and this is a very simple approach. If you are going after LEED, we would have access to your into LEED database that you're working with LEED and USGBC, and it's based off of what they find. So if it's something you guys are going after, we do have an opportunity for it. So the timeline, this is one of the most important slides here, that if you are doing a project to not lose out on incentives. So we keep talking about reservation application. For certain prescriptive measures, it's not required. The ones that are required, it's going to be in the catalog and the application. But this is so you don't lose out on incentives. And also, like with BMS, we need to see your existing system if you have one. So that one does require reservation. Once you submit an application, let's go to this time frame here. It's going to get reviewed by engineers. As Derek mentioned, a simple lighting project, you're switching 10 exterior lights to a new LED. It's a quick turnaround. But for other projects that require more review, it could take 2 to 4 weeks till we get application reviewed, and we'll issue a reservation letter to you. You reserve a project, you have 90 days to install the measures. Like we talked about, a BMS system could take half a year to a full year. Communication, you'll have an engineer working with you, someone from the outreach team. We understand things take time, especially in a big facility and a lot of money. So communication, let us know, because we know that time frame isn't going to work for everything. So letting us know you need an extension, or let us up front know, hey, I want to reserve this, but I'm not going to get it done until towards the end of the year. It's not an issue. So once you install it, same application you're submitting, you're going to use that as a final application. Work's done, we signed off, we've done all this, we're sending you our invoice, our specs, and then we're going to review it again. In 2 to 4 weeks, you have a payment. The payments are a one-time check delivered right to the account. Something just to backtrack a little bit to keep in mind, or talking here, but with the BMS system, again, not watts per square foot, sorry, it's based on square footage, controlled space. We need to see a building drawing of where the system's going. We also need invoices, we'll need a spec of the system. So the more we get up front is going to help speed up that process we just reviewed. So the catalog is the reference you want to always have if you're looking for projects. It's going to spell out the requirements, a sentence or two or a paragraph. Especially on BMS, it's going to say exactly what qualifies. If you have existing equipment, this is what it needs to go to. If you don't have it, so it's going to spell out for every incentive we have what you have to do to make sure the project meets our requirements. It also has information for our ag program I mentioned, and LEED reviews them. So it's really the desktop reference for everything we offer incentive for. The application, again, is used for all of the measures we talked about. Prescriptive, new construction, LEED. It tells you the rate, the unit, what's available. So if you're looking at the application, you see we have incentives for this, we have incentive for that. Then you go to the catalog and say, okay, this is what I got to do to receive that incentive. So use the same application for your reservation as well as submitting the final. Be complete. So that time frame, the better you guys do as customers or contractors, and filling out information is going to help expedite the project. So make sure you have your account numbers, the correct contact name, tax ID up front. So So worksheets, there's worksheets in the application. If anyone hasn't seen it in a while, it used to be almost 40 pages. It's about 18 pages now. So again, there's an incentive for everything electric and gas. If you're doing a BMS project, you're really going to look at 3 pages. You're going to have a customer account page. You're going to have 1 line item, or 2 if it's gas and electric. Let us know your square footage, it calculates the rate for you, and it's a very simple process. This sheet is for the custom. Custom, again, just requires a little more information, telling us this is our total kWh we have now, this is what we're going to, and we're here to help you out with that as well, but it's not a very difficult process. Documentation, again, is key. I'm talking about the BMS system. The better you can do to get information up front helps us know what your project is. We need W-9s, we want to see your invoice, and especially the spec sheets. The final agreement page, once you submit a final, you got to have it signed off by the account holder, letting us know what you've done. We need to see the project cost. But again, make sure you go through the application and fill out everything that's required. The Energy Efficiency Director. The 3 gentlemen who spoke today, obviously very familiar with our program. They can help submit applications, but we do have a Energy Efficiency Directory. You don't have to have a contractor. You can do self-install, you can do projects. You might have a contractor you don't list. We have tons of contractors. We call them trade allies and designated trade allies. This list is only designated trade allies who have come to a training. They know the application process. They're familiar with submitting applications. So this is the one spot we can really send you as a customer to look at different contractors who are available to help you with projects or submit applications. So this is probably one of the most important slides too that everyone saw when they filled out the event. Sharon, you passed around.
Yeah, Mark and I passed, everybody got one.
So what you're looking at is a 30% coupon. Something new we're trying to help you participate and encourage you to do projects. We already pay the $40 and $100 per square foot controlled for gas and electric. This is a one-time 30% bonus on top of those rates. So if you're a gas and electric customer, it's 30% on both of the fuels. Really just trying to encourage you to do a project. Starting next year, we really want to see it reserved in the first quarter, but again, time frame, it might not get paid out until the end of the year. But it's a one-time 30% bonus on top of those rates. And on the back of that sheet, there is 4 simple payback periods to show you examples of what that bonus would do. So now 30%, it sounds like just 30%, but when you actually see what it's doing, it's almost a half to a full year to help you lower that payback period. So take a picture of that coupon too, or the little ticket there so you can hold on to it. But when you fill out the application, that tells you kind of how to do it. You want to indicate that you're using this bonus. And it's one time, one facility. Anyone have any questions on that part?
Comment that I'd like to add to it. Did everybody here sign in? Everybody signed in? Because that is our second level of verification. These really are valuable coupons that you've been given out. It's really a wonderful opportunity to hang on to those. We want to make sure that you're signed in and that you do use that when you move forward on your BMS system.
Say like one facility, you have like a campus of facilities, is that restricting it to particular buildings?
If you have multiple facilities and you're looking to do them, I think like saying communication, reach out to myself or to anyone on the team and we can talk about it.
It's supposed to be on one application,
Okay.
so.
One project.
One project.
One project. Yeah.
So school district would be multiple applications.
Right, so
Yeah,
one
so
application in that district.
You want to pick and choose your largest school districts, I guess, or the one where you get the most ROI out, would probably be the best strategy.
And that bonus pays to the contractor or pays to the
To the customer.
That's to the customer.
It's to help you sell a project. So you got a customer who's maybe not sure if they want to do it, payback's too high, it's up to you to choose when you want to use that bonus to help them drive it in as a contractor.
Does this also apply to custom BMS applications? So,
I think that'd be fine, yeah. obviously we'll talk.
I'm sorry, what?
If it would work on a custom EMS, that's
Yeah.
fine. We're
I
not
think
gonna.
so, yeah, absolutely.
So yeah, something new we're trying, and might be more opportunities like this throughout the year, but really just trying to engage participation. We know this is an expensive project to do, but we also know as we've heard today, it's a very energy efficiency project. So anything we do to help. If there is a project you guys are talking about, again, myself, there's some of the outreach team in the back in gray, Sharon as well. Any questions you have, we're willing to hang out here for a little bit and talk to everyone. You can always call up the program and talk to us. We have a team of engineers and outreach, not just about BMS. We know a lot of schools in here and facilities that there's lots of opportunities, so we're here to help you out along the way throughout next year on any type of project. Any other questions at this time?
Can contact information for the panel
Yeah,
be great?
absolutely. We were planning on sending out a message to everyone that registered afterwards with all their contact information and our contact information. So
Thank you.
we'll make sure you get that. You're welcome.
Nelson?
The coupon is available for the 2019 program year and the 2020 program?
If you have a project that is going to be completed by November 30th, you could apply to that project as well.
Right.
And I wanted to say to the customers, us in the gray shirts, if you're working on some projects in 2020 that weren't addressed today, that you've got questions on, get with one of us in the gray shirts. We will exchange information and help you in the 2020 year. Make sure that you maximize all of your energy optimization projects that are coming up.
Yeah, again, I flew through this to help you guys. I know everyone's got busy schedules to go finish your days, but we do have 3 kickoff trainings that will be announced in a couple weeks here that are in January. Besides our program, there's all sorts of different opportunities, so keep an eye out for the way there was a blast through constant contact or other communication. There is going to be a kickoff meeting that will go more in depth to the training for available incentives and different opportunities. So if anyone has other questions, feel free to ask, or we'll be in here for a few minutes as we wrap up. But
Yeah, I just asked the panel members if they're available, and they said if any of you want to talk to them afterwards, they're open. Feel free. We'll be here.
Thanks to everyone for your time. Thanks for being patient.